These radio waves are among the largest explosions in the universe. When we gaze at the sun, we marvel at the immense power it radiates. While our sun is incredibly powerful, beyond it lies Betelgeuse, a red supergiant star so immense that it dwarfs even the mightiest solar giants. Betelgeuse defies easy explanation with its enormous size, irregular pulsations, and unpredictable behavior, leaving scientists awestruck by its power and potential. As they studied this magnificent star, they made a startling discovery. We'll explore what the James Webb telescope uncovered and how it could revolutionize our understanding. Betelgeuse is visible in the night sky in the northern hemisphere during winter. Many people don't know it's easy to find. Just look at the constellation Orion, and you'll see it as the orange-red star in the top left corner of the rectangle-shaped constellation. It's one of the biggest and brightest stars in the sky. But if you've paid attention, you know it doesn't stay in the same place. It's one of the brightest stars at its best, but sometimes it dims. There's more to it than that. From here, it looks like just another star, but it's not. It's more than 640 light-years away. Even if you could move faster than light, which we can't, it would still take over 640 years to reach Betelgeuse. Our fastest spaceships would take more than 12 million years to get there, longer than the history of all human culture on Earth. Betelgeuse is called a pulsing red supergiant, meaning it's a big old star that gets bigger and smaller, causing the sky to get brighter or darker. These brightness changes can last from a few days to several hundred days, ranging from plus 0.5 to plus 0 magnitude. The smallest changes last 185 days and the longest 2,335 days. Betelgeuse can get very dim. Another term for this is V-band magnitude. In February 2021, a magnitude of plus 1.614 was recorded, the lowest V-band magnitude in a while. It's not as bright as usual, but still quite bright. Betelgeuse is known for more than just its brightness. Betelgeuse shines brightly due to its relatively cool surface temperature of about 3,500 Kelvin, compared to the Sun's 5,500 Kelvin. This lower temperature means it emits less energy per unit area despite its large size, making it appear fainter. It's like a large person who doesn't need to flaunt their size to feel significant. Betelgeuse is a supergiant star, roughly 20 times more massive than the Sun, making it a focal point for scientific study. Named by the ancient Greek astronomer Ptolemy and known in Arabic as the armpit of Orion, it has been prominent in the night sky for millennia. With advancements in telescopes, scientists can now study it in more detail. Analysis of Betelgeuse's light reveals much about its size, temperature, and composition. The Hubble Space Telescope has captured clear images of its surface, showing intricate patterns of gas and dust. The ALMA telescope in Chile has provided detailed images revealing large gas plumes rising from the star's surface, possibly linked to its pulsations. Convection processes cause Betelgeuse to oscillate, creating waves that cause it to expand and contract. Betelgeuse also exhibits dark spots, believed to be magnetic regions where the magnetic field prevents hot gas from reaching the surface, making these areas cooler. The magnetic field on Betelgeuse is thought to be thousands of times stronger than the Sun's, trapping gas in loops or arcs and creating intense magnetic activity. These star spots are larger and more numerous than those on the Sun, sometimes many times the size of Earth and covering up to 20% of the star's surface. Star spots can affect a star's brightness, causing it to vary as these cooler regions emit less light. As the star rotates, these spots come in and out of view, altering its overall brightness. Betelgeuse, for instance, shows brightness changes due to its rotating spots and pulsations, making it highly variable. Similar characteristics are seen in other stars like Antares, a bright supergiant in Scorpius. Antares, much larger than the Sun, with about 12 times its diameter and roughly 700 times its volume, is also a variable star with brightness fluctuations over time. Another example is Mu Cephei, the garnet star in Cepheus, which has a radius about 1,650 times that of the Sun, making it one of the largest known stars. Mu Cephei is also a variable red supergiant like Betelgeuse and Antares. Despite their differences, these stars are unique, each distinguished by its own properties. When compared to our Sun, Betelgeuse is about 1,000 times larger, Antares is about 700 times larger, and Mu Cephei is approximately 1,650 times larger in diameter. Their brightness also varies significantly. Betelgeuse's apparent magnitude ranges from 0.0 to 1.3, while Antares, with similar fluctuations, can occasionally appear slightly brighter. Cepheus, however, shines even more brightly, with its magnitude varying from -3.4 to -5.1. The stars also differ in mass. Betelgeuse is estimated to be around 11 times the mass of the Sun, Antares about 12 times, and Cepheus around 20 times. Each star has unique characteristics. Betelgeuse is known for its pulsations. Antares, surrounded by a cloud of gas and dust, appears less luminous despite being brighter than Betelgeuse. Cepheus is renowned for its brilliance, being among the brightest stars in the sky. These factors all point to an impending supernova event, which could occur very soon. A supernova sounds beautiful when you first hear about it, and in a way, it is. However, it's quite frightening once you understand it. At the end of their lives, some stars explode in supernovas, which are incredibly powerful blasts. These explosions release vast amounts of energy, making them some of the brightest and most energetic events in the universe. Supernovas are primarily classified into two types, Type 1 and Type 2. A Type 1 supernova occurs when a white dwarf star, the dense remnant of a low-mass star, accumulates matter from a companion star until it reaches a critical mass. This triggers a runaway nuclear fusion process, leading to a catastrophic explosion. Although destructive, Type 1 supernovas are relatively less powerful than Type 2. Type 2 supernovas result from the collapse of a massive star that has exhausted its fuel and can no longer sustain nuclear reactions to counteract gravity. The star implodes and then violently explodes, releasing enormous amounts of energy in the form of light, heat, and radiation. The explosion is so intense that it can obliterate everything nearby. In some cases, a supernova can outshine its entire galaxy, although this brightness is fleeting. The supernova will eventually fade away, usually within a few weeks or months. It also produces heavy elements like iron, nickel, and gold through a process called nucleosynthesis, which occurs in the explosion's high heat and pressure. These elements are then dispersed into space, contributing to the formation of new stars and planets. The shock wave from a supernova can trigger the formation of new stars by compressing nearby gas and dust clouds. Supernovas are also useful in cosmology for determining the distance to far-off galaxies. Scientists use them as standard candles to measure these distances because supernovas have a consistent peak brightness. Supernovas are visually stunning, with the expanding cloud of gas and dust from the explosion displaying a variety of colors and shapes depending on the type and location. However, their beauty belies their danger. The high-energy radiation they emit is one of the primary risks. A supernova releases a burst of gamma-ray radiation that can be thousands of times more powerful than the total energy emitted by our Sun over its entire life. This radiation is so intense that it could eradicate all life on Earth by damaging DNA and other biological molecules. Additionally, the massive blast wave from a supernova can travel through space at extremely high velocities, posing a threat to anything in its path. While supernovas help create new stars and planets, they can also disrupt these processes. If a supernova occurred close to Earth, the resulting blast wave could severely damage the planet's atmosphere and potentially lead to the extinction of entire species. Researchers have varying opinions on when Betelgeuse might go supernova. Some suggest it could be tens of thousands of years away, while others believe it might be imminent. The recent dimming of Betelgeuse indicates that this cosmic event could be closer than anticipated. Although Earth is thought to be at a safe distance, the repercussions of such an event are unpredictable. Do you think Earth could be affected by the Betelgeuse supernova?